I'm now going to look at doing hypothesis tests without first finding the critical region. We shall still be using the idea of the critical region, but we will not calculate it explicitly. Let's look at a tetrahedral die, one with 4 faces. Rolled 40 times. If it's a fair die, we would expect 10 ones. And in this trial, we have seen 14 ones. Is there any evidence at the 10% level of significance that the die is biased in favor of rolling a 1? Well, you should be reasonably quick about starting a question like this. They all start the same way. We need the null hypothesis. H0, the null hypothesis, 4 faces equally likely, P is equal to 0.25. So there is my null hypothesis. Then we want the alternative hypothesis. H1, P is, we're looking for an improvement greater than 0.25. And this is the alternative hypothesis. This tells us, because we're only looking at one end, that we have a one-tail test. And it's helpful just to remember what the level of significance is, 10% significance. It's not always 5%, so worth making a note of it. Let's suppose that x is the number of ones. In 40 rolls of the die, then x is going to be binomial 40, 0.25. The test statistic, the statistic that we have calculated from the sample, which we are going to test, is x equals 14. We look at the probability that x is greater than or equal to 14. More about that in the next video. We must use greater than or equal to, not just greater than. 1 minus probability x less than or equal to 13. Using the probability tables for binomial, we get 1 minus 0.9456. That tells us that the probability that x is greater than or equal to, remember the equals, 14, is 0.0544, which is 5.44%, and that is less than 10%. 10% is the significance level that we're looking for. Now we want to know whether x equals 14 is significant at 10%, whether it lies in the critical region. If I take this blue line to represent 10%, where am I going to put it on the graph? Well, we have the probability that we are greater than or equal to 14. This green line is 5.44%. That means that the area on the right is 5.44%. And so if we want to put the blue line on, it must be somewhere on the left of the green line. So if my 10% area is here, this is my critical region. The blue line isn't necessarily in the right place, but it is to the left of the green one. And anywhere that I place the blue line to the left of the green, 14 must be in the critical region. So that is how we think of this one. And really we can say, let's move up a little bit, that as as 5.44% is less than 10%, the blue 10% line will be on the left of the green line, and therefore 14 lies in the critical region. So we have established that 14 lies in the critical region without actually working out what the critical region is. So we reject H0 and we conclude that there is evidence that the dye is biased in favor of rolling A1. Don't be tempted to write down a short conclusion. You should always be copying the question. Full conclusion is needed. Why we use greater than or equal to instead of just greater than is explained in the next video, video 7.2b.